Hey there everybody and welcome. Today we're going to be talking about number sets. So we're given these two sets of numbers here and we're going to just kind of make some observations. Let's look at this first question. It says, how are the numbers in column A similar? And if you want to pause the video and kind of take some notes and make some observations, that would be awesome. So looking at set A, well, you've got a decimal that keeps repeating. You've got a number. I don't know what this random zero is here. I think that's a little misprint, but 89/10. You've got some fractions, some decimals, some positive numbers, some negative numbers. They don't have a whole lot in common. They're just kind of numbers, right? You could say they're all printed in black ink, You can make observations like that. But as far as numbers go, you have a variety of different kinds of numbers. Let's go on to question number 2. How are the numbers in column A different? That's a little bit easier to answer. Okay, so set A, how are these different? Well, you have some positives and some negatives. What else do you have? You have some decimals. You have some fractions, decimals, fractions. You have some integers like 2, -15. Those are your integers. Yeah, that's pretty much how they're different, right? Some of these decimals terminate. When we say a decimal terminates, what does that mean? It means they end. And others have a pattern that just goes forever. Like this is 3's repeating forever, and this is a 1, 2, 3, 1, 2, 3, 1, 2, 3 repeating forever. So some terminating, and that's supposed to say terminating, and some repeating decimals. All right, I think that's a pretty good list there. What about column B? How are the numbers in that column B similar? Look at these. What do you think? What's similar about all those? I mean, they're all kind of different from each other, right? But you know what they have in common? None of them are just regular old numbers. There's no like 5 or 8 or even 1/2 or 0.2. Nothing like normal. None are regular numbers. I can't write when I'm under pressure, apparently. None are regular numbers. There we go. Hopefully, oh, you can't read that, can you? There we go. None of them are regular numbers. What about how are the numbers in column B different? Okay, let's look for differences here. Well, some are decimals, like these are decimals. Some have radical symbols, they're like roots. Some are roots, and one is even a symbol. So you've got decimals, roots, and symbols all together. By the way, let's talk about that symbol. This symbol has a special name, and if you don't already know it, it's called pi. And the number for it is 3.1415, and it goes on forever and ever. You could write 1 billion digits of pi and you still wouldn't be done because it is infinite. It never stops. So it's just one of those. That's what this is. All right, let's go ahead and compare these two sets of numbers. How are the two sets of numbers similar? Okay, well, what do they all have in common? I mean, each set has a variety of different kinds of numbers. Like there's some decimals, some fractions, some roots. So I'm just going to say, in terms of how they're similar, it's a variety of numbers. You guys might come up with something better. If you do, feel free to share it with me. But a variety of numbers. Now, how are they different? This is a little bit easier to pin down. Let's take a look. So there's some fractions over here. Are there any fractions over here? No, I'm going to say set B has no fractions. Set B has no fractions. All right, is there anything else that set A has that set B doesn't have? Well, you've got these decimals that repeat, like 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 3, 3, 3, 3, 3 forever. Does set B have any of those repeaters? No, it doesn't. Set B has no repeating decimals. Okay, what else does set A have that set B doesn't have? Well, we've got what we call the terminating decimal, meaning that it ends. It doesn't go on forever. So it also has no terminating decimals. And Set B, let's see, does it have any of these integers? Nope, no integers over there. So let's write that down too. Set B has no integers. Okay, so we're making some good observations here. Let's go ahead and flip to the next page. What we're talking about today is the number system, right? And when we're talking about all these things like in set A and set B, we're generally talking about rational numbers versus irrational numbers. And the rational numbers, that name, that label corresponds with everything that we saw in set A. All of these guys, these are your rational numbers. And then set B, these are your irrational numbers. Irrational. Okay, so let's label that over here, set B. All right, so let's give you some examples. Examples of rational numbers. You might have just a random whole number, or you could have something with a repeating decimal, 2.25. I'm going to use my little repeating symbol there. What if you had a fraction, 1/8? Yeah, that's a rational number. What if it was a negative fraction? Yeah, sure, that's a rational number too. What if you had a square root of 81? Well, let's see, square root of 81 is 9 or negative 9, and those are both rational numbers, so that goes there too. So we've got some examples of rational numbers here. Oh, and also terminating decimals. So you could have just like 6.12, and then it stops there. Those are all rational numbers. Okay, what about irrational numbers? So these irrational numbers, you noticed over here that there were no fractions, no repeating decimals, no terminating decimals, and no integers. So everything that we have either has like a ... after it, and that just means it keeps going forever. Now look here, the ... here just means that it's repeating. They could have just as well written one of these guys. But over here you see it's a whole bunch of different numbers and then a ... That means it doesn't repeat and it's irrational. So under irrational numbers, let's just make up a decimal. Let's do 3.192648117, and then we're going to do our ... just to indicate that it's going on forever and never repeating and never making a pattern. Now speaking of patterns, over here, see this one? It's 10, 100, 1000. This is a pattern, right? It's just one more zero in between each time. But it's not, strictly speaking, a repeating decimal because the pattern is changing each time. See how it's getting longer? It's not like you could just copy and paste it on a computer and do it a million times and it's all the same. It changes, and so it is irrational. Same thing here. There's a pattern. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You could complete the next 20 digits if I asked you to, but is it the same pattern repeating over and over? Is it like 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4? No, it's not. It's different numbers each time. So even though there's a pattern you can find, it is not a repeating decimal because the numbers are not repeating the way they are here and here. Okay, so back to this. Irrational numbers, we've got that. Remember, we've got our pi here. We've got some certain square roots. Square root of 81 we talked is rational because it just is 9. But what if you did the square root of 2? This is a famous irrational number. Let's see what happens when you put that in the calculator. So let's clear that out. Square root of 2, and it's going to give us, well, it gives us that. And then we have to push this button right here, the fraction to decimal button. And it goes 1.414, 213,562. You see how it just kind of maxed out the space for decimals and then it stopped? When it fills up that whole space and nothing's repeating, that means that it's irrational. So square root of 2 is definitely going to be irrational. Kind of like these guys were. Let's do this cube root of 17. Let's see what that looks like. So cube root of 17. And again, it's going to be nice long going all the way to the end of the screen, and it's not repeating, so we know that's irrational. Irrational. Okay, so those are some irrational numbers. They can be positive or they can be negative. I could easily write a negative. Here, let's do the negative cube root of 17. How about that? Okay, now let's go on back over here. So under the set of rational numbers, you see how these squares are all inside of each other? Well, some rational numbers are also what we call integers. Now, as you may remember, integers they can be positive or they can be negative, they can be 0, but they can't be like fractions or decimals. So your integers are going to be like 10, -6, 0. You could say like 12 over 2 because when you simplify that, that becomes a 6, right? Or you could say the square root of 25 because the square root of 25 is a 5. So all of these would be integers. Now when you get down to whole numbers would just be 0 and up, the integers that are 0 and up. So it could be 0, 1, 2, 3, it could be 2,000. You know, those are your whole numbers. Your counting numbers, on the other hand, like when you were a baby and you learned to count, you probably didn't start 0, 1, 2, 3. Most kids go 1, 2, 3, 4, right? Those are your counting or natural numbers. So it's 1, 2, 3, 4, and up. And so those are your numbers. Now, like I was talking about, these squares are all nested in each other. So these numbers that are natural numbers, counting numbers, they are also whole numbers, integers, and rational numbers. So if I asked you what kind of a number is a 4, you could tell me it's a counting number. You would also tell me that it's a whole number. You would also tell me that it's an integer, and you would also tell me that that number is rational. All right, but what if I asked you about the number -6? Is -6 a whole number? No, whole numbers, that does not include negative numbers, so it's not a whole number. It's not a counting number either because no negative numbers are here in the counting numbers. So if I asked you something about like about -6, you would say it's an integer and you would say it is rational. Now if I asked you about this guy, 6.12, well, it is not an integer, it's not a whole number, and it's not a counting number. This one is just a rational number. So that's how that works. And on your assignment over here, you're just going to kind of go through and label these. So like for 1.25 with that 25 repeating, you would say, is it rational or is it irrational? And with a repeating decimal, it's going to be rational, right? So you would write rational here. And then over here, you would write any other labels that apply. You would identify what number sets it belongs to. So if it's rational, you would write rational again, or you could just abbreviate it. You could write rat if you want, that's fine. And then you're going to say, does it belong to integers? Does it belong to whole numbers? Does it belong to counting numbers? And if it doesn't, you're done. But if it does, then you need to list them all out. And with the numbers that are irrational, you'll just basically write irrational here, and you'll also write irrational over here. All right, I hope that gives you some guidance. Let me know if you have any questions. Let your teacher know. We'd love to hear from you. And I'll see you next time. Bye.